There is something deeply unsettling about the speed of light, and it has nothing to do with how fast it travels. The unsettling part is the reason it cannot be exceeded. Most people, when they hear that nothing can travel faster than light, imagine some kind of cosmic traffic law, a rule imposed from outside, the way a government sets a highway speed limit. But that picture is completely wrong, and correcting it opens a window into one of the most profound and strange aspects of physical reality. The speed of light is not a rule, it is a geometry. And once you see it that way, the universe begins to look less like an open stage and more like a carefully sealed structure, one in which every event, every signal, every cause, and every effect is locked inside an invisible geometric cage. Let us start with what physicists actually call it when they are being precise. The symbol is c, and its official definition is the speed of light in a vacuum. But that name is almost a historical accident, a relic of the fact that light was the first thing we measured moving at that speed. The deeper truth is that c is not the speed of light in any fundamental sense. It is the speed of causality. It is the maximum rate at which any influence, any signal, any piece of information can propagate through the universe. Light happens to travel at c because photons are massless, and massless particles have no choice but to move at that speed. But if photons did not exist, c would still exist. The universe would still have that limit baked into its structure. The number would still be approximately 299,792,458 meters per second, and nothing would be able to exceed it, not because of any law written by anyone, but because of the shape of space-time itself. To understand what that means, you have to stop thinking of space and time as two separate things. That separation is intuitive. It matches our everyday experience, but it is a low-resolution picture. The more accurate picture, the one that Einstein and the mathematician Hermann Minkowski worked out in the early 20th century, is that space and time are not independent. They are two aspects of a single four-dimensional structure called space-time. Every event, every moment at every location is a point in that structure. And the geometry of that structure, the mathematical rules that define how distances are measured, how intervals are calculated, how events relate to one another, that geometry is the source of c. In ordinary three-dimensional space, the distance between 2 points is calculated using the Pythagorean theorem. You square the differences in the three spatial coordinates, add them up, and take the square root. That gives you the spatial separation. But in four-dimensional space-time, the calculation is different. The quantity physicists care about is called the space-time interval, and it is calculated by taking the spatial separation, subtracting the temporal separation multiplied by c squared, and taking the square root of the result. That minus sign is not a typo. It is the entire story. That minus sign is what makes space-time fundamentally different from ordinary space, and it is what creates the speed limit. When you move through space-time, you are always moving. Even if you sit perfectly still in your chair right now, you are moving through time. Your path through space-time, what physicists call your world line, is always advancing. The question is not whether you move through space-time, but in which direction you move. And c is the parameter that defines which directions are available to you. Here is the key insight. For any event, any point in space-time, there is a set of directions you can move without violating the geometry of the interval. Those directions are defined by the light cone. Imagine placing yourself at a single point in space-time, a single moment at a single location. From that point, draw all the possible paths that a light signal could take, radiating outward in every direction through space as time advances. Those paths trace out a cone shape in the space-time diagram, opening upward into the future. Now draw the same cone going backward, representing all the light signals that could have arrived at your location from the past. You now have two cones, one opening toward the future and one opening toward the past, joined at your current event. That double cone is the light cone, and it is not a visualization tool. It is a statement about the structure of causality. Every event that falls inside your future light cone is an event you could, in principle, influence. You could send a signal there. You could travel there. You could cause something to happen there. because there is enough time for any influence traveling at or below c to connect your location to that event. Every event that falls inside your past light cone is an event that could have influenced you. A signal from that event could have reached you by now because it had enough time to travel the distance at or below c. Everything outside both cones is causally disconnected from you, not merely unreachable in practice, unreachable in principle, not just difficult to influence. Geometrically impossible to influence or be influenced by. This is where the word prison becomes accurate, and it is worth being precise about why. The events outside your light cone are not cut off from you because of practical limitations, the way a distant city is cut off from you because you do not have a vehicle fast enough to get there today. They are cut off from you because causality itself, the very connection between cause and effect, cannot stretch that far from your current position. If you tried to influence an event outside your light cone, you would need to send a signal faster than c. And a signal faster than c would, in the mathematics of special relativity, be equivalent to sending a signal backward in time. It would arrive at its destination before it left its source. Cause would follow effect. The logical structure of events would break down. The universe does not permit this, not as a matter of policy, but as a matter of geometry. The road simply ends. Now think about what this means for the stars you see when you look up at the night sky. When you look at a star 40 light years away, you are not seeing that star as it is now. You are seeing light that left that star 40 years ago, light that has been traveling across space for 4 decades before finally reaching your eyes. That star, as it exists at this moment, is outside your current light cone. Its present state cannot affect you yet. You are not in contact with the star as it is. You are in contact with a message it sent 40 years ago. And that message, those photons, are all that connect you to it. Think of it this way. Imagine receiving a letter from someone who lives on the other side of the world. The letter takes weeks to arrive. You read the words, you understand the thoughts, but the person who wrote those words is weeks older now, perhaps changed, perhaps gone. The letter gives you information about a moment in the past, not a window into the present. Now scale that idea up to cosmic distances and replace the letter with light. Every star you see is a message from the past. The more distant the star, the older the message. Some of the stars visible to the naked eye sent their light to you thousands of years ago. The galaxies visible through a telescope sent their light millions or billions of years ago. The universe you observe is not a snapshot of the present. It is a layered archive of the past, organized by distance, because distance determines how long the light has been traveling. And here is where it gets stranger still. The universe is not static. It is expanding. Space itself is stretching. And at sufficiently large distances, the rate at which space expands between 2 points can cause those points to recede from each other faster than light. This does not violate c because no signal is traveling through space faster than c. Space itself is simply growing, carrying points apart. But the consequence is that there exists a boundary called the cosmic horizon, beyond which light from distant objects can never reach us, because the expansion of space will carry those objects away faster than their light can cross the growing distance. Those regions of the universe are not merely far away, they are permanently outside our light cone. Not just today, but forever. Any events happening there, any stars forming, any processes unfolding, none of it can ever causally connect to us. We are sealed from it, not by walls, but by geometry and by the expansion of the fabric in which we are embedded. This raises a point that physicists find genuinely profound. The observable universe, the region of space from which we can in principle receive signals, is finite. It has a size, not because the universe itself is finite, it may well be infinite in extent, but because our past light cone has a finite volume. We are surrounded by a horizon, and that horizon is a causal boundary. Beyond it lies a universe we are completely severed from. Within it lies everything we can ever know, everything that can ever know us. Now return to the photon itself, to light, and consider its path through space-time. A photon travels at exactly c. In the geometry of the space-time interval, this has a remarkable consequence. Calculate the interval along the path of a photon, the space-time distance between any two events on a photon's world line, and you get zero, not a small number, exactly zero. Physicists call this a null path, or a null geodesic. The photon's path through space-time has zero length in the geometric sense, even though the photon crosses enormous distances in space and takes enormous amounts of time to do so. From the perspective of the space-time geometry, the event of the photon being emitted and the event of the photon being absorbed are, in a precise mathematical sense, the same event. There is no interval between them. Time does not pass along a null path. This is not a poetic statement. It follows directly from the mathematics of the space-time interval. And it tells you something important about what C actually represents. It represents the boundary between two fundamentally different categories of path through space-time. Paths with positive interval, called time-like paths, are the paths available to massive objects like you. These are paths that stay inside the light cone, paths where there is always more time separation than space separation, paths where cause can precede effect. Paths with negative interval, called space-like paths, are the paths outside the light cone, paths that would require faster than c travel, paths that are causally backwards. The photon's null path sits exactly on the boundary, on the surface of the light cone, with zero interval. It is the geometric edge between the possible and the impossible. Massive objects cannot reach that edge. As you accelerate an object with mass towards c, the energy required increases without bound. This is not a technological problem. It is a consequence of the relativistic relationship between energy, momentum, and mass. The kinetic energy of an object approaches infinity as its velocity approaches c, which means no finite amount of energy can push it all the way there. The light cone surface is an asymptote. You can approach it, but never touch it. Massless particles like photons live exactly on it. Massive objects live inside it. Nothing lives outside it. What this means for our picture of reality is something physicists have spent over a century absorbing. The universe is not a single connected whole that exists simultaneously and can be known all at once. It is a collection of causally separated regions, each sealed from the others by the geometry of space-time. Every observer carries their own light cone with them, their own causal bubble, their own geometric prison. What falls inside that bubble is the universe that observer can know and affect. What falls outside is, for that observer, simply not there in any causal sense. It exists in the sense that space-time has extension in those regions. But it cannot reach you, and you cannot reach it. When you look up at the night sky, you are not seeing the universe as it is. You are seeing the universe as it was, at various different times, each time stamp determined by how far the light has traveled. The universe you live in is not the universe as it exists in the present moment. The present moment, as a global concept, is itself not well defined in special relativity. Simultaneity is relative. What is simultaneous for you is not simultaneous for someone moving at a different velocity. The present is local. It is your present, defined by your position and your motion through space-time. The rest of the universe reaches you only as history. And so c, this number we measure in meters per second, this apparent speed limit for light, turns out to be something far more fundamental than a velocity. It is the conversion factor between space and time in the geometry of space-time. It is the parameter that defines the shape of light cones. It is the boundary between what can communicate and what cannot. It is the constraint that makes cause precede effect and not the other way around. Without C, there would be no consistent causal structure. Every event could influence every other event. The very notion of an ordered sequence of causes and effects, the notion of a story with a beginning followed by a middle followed by an end, would be incoherent. The speed of light is, in this sense, the speed of causality. It is the rate at which the universe is willing to let one thing lead to another. And the fact that it is finite, the fact that it is not infinite, is what gives the universe its structure. An infinite speed of causality would mean instant connections across all distances, a universe with no causal hierarchy, no meaningful notion of before and after. A finite C means that the universe has a geometry, that events are ordered. that information propagates at a rate that preserves the logic of cause and effect. We live inside light cones. We move through space-time on time-like paths, always inside the cone, always subject to the constraint that the interval we trace remains positive. Every signal we send, every message, every photon we emit travels on or inside the light cone, never outside it. The events we can reach are precisely those events the geometry allows. The rest of the universe, the vast majority of space-time by volume, lies outside our causal reach, not because we lack the technology to cross it, but because crossing it would require erasing the distinction between before and after, between cause and effect, between signal and response. That is the prison, not a prison of iron bars or locked doors, but a prison of geometry, a constraint so deep it is woven into the fabric of what space and time mean. A limit that is not enforced from outside, but that arises from the very structure of the four-dimensional manifold we inhabit, and within that prison, the universe has given us something remarkable. A finite but rich bubble of causal contact, a region of space-time we can know and interact with, a light cone filled with history and possibility, within which